last class this semester, and we have learned almost all points of the textbook. Now today we will review from the beginning. Last time we have reviewed through this outline for review PDF files. And we will review some calculation problems. For example, the channel capacity. If noisy, we were using Shannon. We will use Shannon theory. If noiseless channel, we will use next theory to get the maximum data rate or the capacity of the channel. Then we introduce the CRC calculation. Okay. And we will have some short answer questions. For example, explain some short terms. And we introduced the reviewed subnetting calculation. And we review the CIDR calculation. For example, CIDR block is given, and several universities applied address block. And if you are ISP, if you are address manager, then how to assign address block with CIDR method. So we explained this kind of examples, and we reviewed data link protocol, the utilization of data link protocol. For example, ARQ protocol, stop and wait protocol. So if you understand the principles of this kind of protocol, I think it is not difficult. And about local area network, we have illustrated the Ethernet. Some calculation problems of Ethernet. For example, the minimum length of a frame. So the minimum length of a frame, the intention period, or the collision detection time, maximum collision detection time, 2 times tau times c. Then we get the minimum length of frame. Here, capital C is the data rate. And we will illustrate some kind of questions. Then we illustrate the Wireshark and the capture and analysis of packets captured with Wireshark, and the information captured with Wireshark is given. Then we can determine the value of each field of the header packet, and we can determine the meaning if the value of the field is given. So then during the final assignment, then the appendix Ethernet frame format, IPv4 packet format, protocol number UDP datagram format, TCP segment format, and well-known port number table will be provided for you. So what you should do probably is filling the information carefully into the fields of the protocol head. Then we can get each value, the value of each field, right? Reasons for using layered protocols. What is the one possible disadvantage of using layered protocols? Among other reasons for using layered protocols, using them means to breaking up the design problem into smaller, more manageable pieces. And layering means that the protocols can be changed without affecting older ones. One possible disadvantage is the performance of a layered system is likely to be worse than the performance of the monolithic system, although it is extremely difficult to implement and manage a magnetic system. So, layered protocol system and monolithic system, we all have advantage and disadvantage. So you should analyze and why we use layered protocols in the network. Here I illustrate the answers. Okay. Chapter 2, physical layer. So in the review PPT, I select some typical questions, but in the exercises we have many questions. Now about the short answer questions, please write the full names of 4 multiplexing techniques in the physical layer and describe the main function of the physical layer and the noisiness channel and the noisy channel. We should calculate the capacity of the channel. About the CRC calculation, okay? CRC to determine the to be transmitted frames. This kind of question. The other kind of questions is for the receiver. In the receiver end, the receiver should determine whether the message received is correct or not. So question 5, it is done in the sending end. Question 5 is at the sender end. Question 6 is at the receiver end. Do you understand? Question 5 is when the message should be transmitted, we should calculate CRC code, CRC check-in sequence, and determine the to be transmitted frame with or appending with CRC check-in sequence. But question 6 is if the receiver received a kind of data sequence, then the receiver should determine whether the data sequence received correct. And so please write out the checking process at the receiver end. That is different. So in the review PPT, I showed question 5, right? Now I will illustrate the answer of question 6. Sorry. Question 6 is a communication link use CRC with the generator polynomial x4 plus x plus 1. Assume that the data sequence with CRC code. Okay, here it is 4, right? So the CRC code lies at the last 4 bits. The message is 1011. So what is the length of the CRC code? 4 bits, right? What is the binary bit sequence of the polynomial? generator polynomial, then 1, 0, 0, 1, 1. Here 0, 0. We have no x3, x2, right? x3, x2. No, these two terms. So 1, 0, 0, 1, 1. Then is the data sequence received correct or not? We should use this non-division. Here, no 0 bit appended because it is the data sequence received with CRC code. It is in the receiver end, so the CRC code appended already. So no 0 bit appended at the receiver end. Okay, so here is 0, the remain 0. So it is correct. Data sequence received is correct because the CRC remained 0. You understand? Do you understand? Okay. Chapter 3, we have illustrated the questions through review PPT, okay? Through review PPT, right? Stop and wait. Stop and wait. Protocol, ARQ protocol with different transmission window size, such as 7, 127, etc. So we should draw this kind of graph to analyze the utilization. This is transmission time of a frame, and this is the round trip propagation time. The round trip propagation delay 2 times TP. So the utilization is TS over TS plus 2 times TP. And for ARQ protocol, then transmission time totally is the window size. Here it is 3, right? WT times TS, and the length of the period of the term is TS plus 2 times TP, right? So we can determine the utilization. Right? Okay. Do you understand? Okay, then we will continue to review the next chapter. Chapter 4, the Medium Access Control Sublayer. This kind of questions is very easy, right? Very easy. The minimum length of a valid frame in Ethernet is 64 bytes. 64 bytes. The short answer questions. Write the full name of CSMACD and describe it briefly. Carrier sense multiple access with condition detection. It's the full name of CSMACD. And you should describe briefly what is the carrier sense, what is the multiple access, what is the condition detection. So if there is 6 points for question 1, then each point has 2 points. Carrier sense, multiple access, and condition detection. Each point has 2 points. Question 2, please describe briefly the reason why Ethernet specifies the minimum valid frame length and the maximum transmission unit, MTU. Understand? The class has begun. Why, you ask, is the class started? I don't understand. Okay, for example, the short answer questions, please describe the reason why we need the maximum, why we need to specify the minimum valid frame length and the maximum transmission unit. Okay, then no, the class has started. Probably you should update the mini application. Okay, comprehensive application questions. assume that in CSMA-CD Ethernet, the distance between station A, B, and B is 4 kilometers. The propagation speed of the signal is 2 times 10 the power of 8 meter per second. Data transmitting rate is 100 megabps, and the station A sends a frame earlier than B. Then a collision occurs. Please determine how long does it take as soon as possible for station A to detect the collision. How long does it take at the latest for station A to detect collision? If the distance between station A and B is shortened to 2 kilometers, what should the minimum frame size be for this Ethernet? So we should depend on the equation of the minimum length of a frame. The minimum length of a frame is the round trip propagation delay, 2 tau times c. Tau is the one-way propagation delay. Tau. The c is 100 megabps. Okay, so we can determine this. We have illustrated when finished chapter 4, right? Consider question 2. Consider a CSMA-CD LAN running at 100 megabps over 1 kilometer cable. The signal speed in the cable is 200,000 kilometers per second. What is the maximum contention slot? What is the minimum frame size? Okay, the signal propagation delay is tau equals L divided by V. The maximum contention slot is 2 tau. The minimum frame size is L min equals 2 tau equals 2 tau times C, right? 2 tau times C. Okay. Question in the chapter 5. I have illustrated. Okay, so I will not repeat. Especially the capturing and analysis of the information captured with Wireshark. Probably we have this this kind of information, then we can determine the field in the particle head. Determine the value. And this kind of appendix will be provided for you. So this is the answer. Pay attention. Please pay attention. Probably the information in the final assignment may be different from this, maybe different. So maybe modified. So if you remember these values, it's of no use. So you should grasp, you should understand the method. Okay, let's have a rest for 10 minutes. Let's have a rest for 10 minutes.